Bismillahirrahmanirrahim. Question number 6 is from the trigonometry of P3. It says express um, this given expression into this form. So you have to see that if you have to write, like sometimes you have to write this into r cos something or r sin something. So if your expression has to be written in terms of cos, then this should be starting from the cos. Okay? And secondly, in case of cos, if there is theta minus alpha, there has to be plus between these terms here. Okay? So if this is matching, then you can simply say that your A is going to be under root 6 and your B is going to be 3. And you have the formulas for R and this alpha. R is going to be the square root of A square plus B square. And your alpha is tan inverse of B over A. So this way, you have this R that is going to be the square root of the 6 plus 9, that is under root 15. And you see that we have to give the value of R in exact form. It says state the exact value of R. So that is under root 15. And then you'll find the alpha. So that will be, that is going to be, alpha is going to be tan inverse of this 3 over under root 6. Do you have the calculator? So what is that? Okay, yeah, correct. To two decimal places is 50.77. Therefore, this uh, under root 6 cos theta plus 3 sine theta is going to be written as under root 15 cos theta minus 50.77. So this is for the 3 marks, okay? And then you move on to the second part. It says, hence solve the equation this. Okay? So you can compare this equation, this given form, with this form over here. Okay? Look at this. This has got theta in it, and this has got 1 over 3x in it. So that means using this hence, you can write this thing as under root 15 cos 1 over 3x and then minus 50.77, that is equal to 2.5. It becomes a simple equation but still with a composite angle, so we have to deal with this composite angle right now. So we shall say okay, no problem, uh, let this 1 over 3x minus 50.77, that is equal to, let's say we keep that equal to y. So this equation becomes under root 15 cos y, that is equal to 2.5. So this cos y is going to be 2.5 over under root 15. We must state the limits, the domain of this y, because now our equation in terms of y. So using this relation here and these given limits of x, we can write the limits for y. Okay, ji? So this y is going to be, when you put the lower limit of x, which is 0, so 0 minus this is going to be minus 50.77, and one third of 360 is 120 minus 50 is 70. So 60.23. Sorry, 69.23. Can you please check that, beta? 120 minus 50.77. Okay, it is 69.23. So our y has to be between these two limits here. Now this is, if you, I should have drawn that towards the right side of my work, but I'm sorry, I have space here. Now you find the cos inverse. Since it is positive, so I'm marking these two quadrants here. Okay? So the cos inverse of 2.5 over under root 15 is 49.80. This is 49.80. So you have to decide now, can we have our first angle as minus 49.0, because we can go up to uh, here up to minus 50.77. So yes, the first value of y is going to be minus 49.80, and then there is also 49.80. So these are the two values of y. By seeing this, you can get the values of x now. If you just rephrase this equation here, this is going to be 1 over 3x, that is y plus 50.77. So your x is 3 times y plus 50.77. So when you have y is equal to minus 49.80, this is going to be 3 into minus 49.80 plus 50.7. So what do you get, beta? Okay, so by replacing the second value of y, which is 49.80, you get what is the second 300 and? So it's 301.7. So you must keep your final answer correct to one decimal places. Okay? Okay? So that is the answer to this question. Okay? I am going to move on to the next question now. This is question number 7. So we have done this question in a very different way. You see that normally when you have to verify that something is a root of a given equation, we normally put that value of x into the equation, and this should satisfy the equation. Okay? But we have done this in a different way. Let me tell you, this will help you to get to the part B very easily. Okay? If you look at this part B, you have to find all the roots of this equation. Okay, na? So let me write it this way. Can I say that if x equal to minus 1 plus under root 5 iota is a root of this equation, then this implies that there is another root, that is minus 1 minus under root 5 iota also. Okay? Because substituting this point into over here, there is a lot of working. Okay, na? So let me make you recall the fact that if you have a root which is x equal to alpha, and then there is a root x equal to beta, then if you write it like this, x squared minus alpha plus beta x plus alpha beta, that is the equation of that equation which has these two roots. So we can find that equation which has these two roots. So what is, if this is your alpha over here and this is your beta over here, so can I say my alpha plus beta is going to be minus 2, and my alpha beta is going to be, if you remember, a plus iota b times a minus iota b, that is going to be equal to a squared plus b squared. So this way, this is minus 1 plus under root 5 iota, and this is going to this is going to give us 1 plus 5, and that is going to be equal to 6. You see that how easily we get to that quadratic factor of this. The quadratic factor of this is going to be x squared plus 2x plus 6. This time, this is the equation which has these two roots. So if I divide this given cubic equation with this, and if I divide that completely, that would verify that this is really a root of this given equation. So let's do that. This is going to be 2x cubed plus x squared plus 6x minus 18, and this one is x squared plus 2x plus 6. So this is 2x over here, This is 2x cube plus 4x square plus 12x. Okay? So we subtract all of them, we get minus 3x squared minus 6x minus 18, and then this is into minus 3 will give us minus 3x squared minus 6x minus 18. So all of this is cancelled out. So this means that this implies that minus 1 plus under root 5 iota is a root of the given equation. ठीक है? That is the root of the given equation. ठीक है बच्चों? So that is how you do this part. And if you don't like all this working, basically you will have to do all this working in the next part again. I'll tell you why. But if you want, you can also substitute this minus 1 plus 105 iota into it. Through the binomial expansion, you can get all of this equal to 0 as well. So the choice is yours. If you think that this one is lengthier working, then you can simply substitute. Straight away method is that you simply substitute this into this. But a bit smarter way is also, you see, you can avoid using all those binomial expansions and iota cube and iota square and all that. So many simplifications can be avoided if you use this method. Okay? Now, if I take you to the second part here, it says find the other roots of this equation. Now, all this working can be stated again. You can say, okay, look, if x is the root of this, then the second root is this, and you can tell that this is the conjugate pair of that. Okay, you can tell that this one is the conjugate. है So this is the conjugate. So this is the quadratic factor of this given polynomial. You divide this. So you have already got two roots from this. One is this, the other is this. The third root is going to be this one. Because this time this is going to give us this one. So you can state, let me have some space over here. You can state here, okay, G, let me cover this space here. You can tell the examiner, okay, look, this f of x is equal to x square plus 2x plus 6 times 2x minus 3 equal to 0. So x square plus 2x plus 6 equal to 0 gives us x equal to minus 1 plus under root 5 iota minus 1 minus under root 5 iota, and 2x minus 3 equal to 0 gives you x equal to 3 over 2. That is the third root of this equation. Okay? So I move to the next question. Question number 8. Question number 8 is a straightforward question on differential equations. It's a straightforward question because you don't have to form an equation and then you have to solve that. So I'm going to solve that right away. So I have one side with the dy. So this is going to be dy over y. And the other side has 1 minus 2x squared over x dx. So I integrate this with respect to y, and this is going to be integrated with respect to x. Okay? Now this can be splitted into 1 over x. This is what you people have to identify, that what technique has to be applied to integrate the given expression here. So this will give you ln y, that is going to be equal to ln x, and this is minus x square, and then you have plus c. Now using these given values of y and x, we can determine the c. So this is ln 1 equal to ln 1 minus 1 plus c. So we have c equal to 1. Therefore, we have ln y equals ln x minus x square plus c. So we can write this as y is equal to e raised to power ln x minus x square. This is, I should write here c's value, which is going to be plus 1. Achha, this is plus 1 here. You can leave this up to this part. That is your y in terms of x. This is the answer, okay? But if you see that you can still write this as y is equal to e raised to power ln x into e raised to power 1 minus x square. You know that e raised to power ln x is going to be x. So you can also write it as y is equal to x e raised to power 1 minus x square. But if you have left your working up to this part, this is going to give you full marks as well, because the demand of the examiner was that you have to write y in terms of x, and this is y in terms of x. Okay, let's move to the question number 9. Question number 9. Okay, here is question number 9. We have to express f of x in partial fractions. Now, when I have to do that, bacho, I should check that what do I have to do in the b part. Okay, let's see what is there in the b part. In b part, it says it is about the binomial expansion. So guys, if you have to expand this using the binomial expansion, you should try to write the smaller number of fractions, minimum number of fractions. And if I had to integrate in the b part, then I would have gone for the greater number of fractions, because integration is easier when you have, your expression simplified, more simplified. Okay, so I will be writing just two fractions for this. Okay, so let me write it this like this. A over, this is a over 1 minus x plus bx plus c over 2 plus 3x whole square. Please remember, I could have also written it like this: a over 1 minus x plus b over 2 plus 3x plus c over 2 plus 3x whole square. But I will not be doing this, because I want to write the minimum number of fractions, as I have to go for the binomial expansion. Now, this numerator over here becomes 8 plus 5x plus 12x square. That is equivalent to a into 2 plus 3x whole square, and then bx plus c times 1 minus x. Now we have to get the values of a, b, and c. I should I'll be putting x equal to 1. This will eliminate all of this, and I'll be able to get the value of a. So when I put x equal to 1, I have 8 plus 5 plus 12. And that is a into 2 plus 3 whole square. So we have 25 equal to 25a, and your a is equal to 1. That is how you get to the value of a. Now, looking at this bx, if I put x equal to 0, I'll be able to get rid of this b, and I already have this a, hence I'll be getting the value of c. So let's put x equal to 0. So I have 8 on this side, a is 1 into 2 square, and then I'm left with c into 1. So the c is going to be 8 minus 4, that is equal to 4. Okay? Now you can put, we have got two of the unknowns here. We have to find the value of b. We can substitute this x as minus 1 or any other value of x. But I would be finding this b by comparing the coefficients of x square. Okay? I have 12 on this side. If you imagine its expansion, you will have 9x squared in this expansion. So that will give me 9a, and bx into minus x will give me minus bx squared. This is going to be minus b. So this b is going to be 9 minus 12. So this b is equal to minus 3. Therefore, This is going to be now, this is going to be 1 over 1 minus x, and this is 4 minus 3x. Okay? So let's see what do we have up to what we have to expand this up to x square. Okay. So we have to expand this up to x square. Okay. Here we are up to x square. Let me cover this working. Okay. Acha bacho. So um, this means my f of x is going to be f of x is now equal to 1 over 1 minus x. We are happy with this because the first term has to be 1. Okay. There is no need to be bothered about the numerator. It is already expanded. Okay. But we need to make this 2 1 over here. This is your 2 plus 3x whole square. I'll have to take this 2 out. So when I take it out, this becomes 4 because of the square on these brackets, okay? This is basically 2 plus 3x whole square. When I take 2 common from this, so since there is a square, sorry, what am I writing here? Um, this is 1 plus 3 over 2x. So I have to put the square on both of them. So this will give me 4 into 1 plus 3 over 2x whole square. This is going to be 1 minus x to the power minus 1 plus 4 minus 3x over 4 into 1 plus 3 over 2x to the power minus 2. ठीक है? अच्छा बच्चों, let's expand this using the binomial expansion. This is 1 plus n x plus n into n minus 1 over 2 factorial into x square. We have to keep it up to x square. So I'll just put some dots here. Then we have 1 over 4 multiplied inside, this is 1 minus 3 over 4x into, I have divided this 4 by these two terms here. Sorry, these two terms are divided by 4 actually, okay? Now this is 1 plus n into x plus n into n minus 1 over 2 factorial into this x square and dots here. Okay? So now we have equals 1 plus x. Now all of this is cancelled, so you have plus x squared. We have plus 1 minus 3 over 4x. You have to be very patient, go slow, okay? There are 5 marks, see? So hasty work can result into a loss of marks here. This is 1. This 2 is cancelled by this. This is going to be minus 3x. And then this 2 is cancelled by this 2. Minus into minus gives us plus. There is going to be plus 3 into 9 over 4x square. That is 27 over 4x square. Okay? But so you must have your calculators with you because there are lot many fractions here. So don't try to uh, make any mistake while trying these things mentally if you're not good at that. Okay? 1 plus x square. Now 1 into 1 is going to give me 1. I'm going to write under this. 1 into minus 3x is minus 3x. I'm writing under this. 1 into this is going to give me 27 over 4x square. Now minus 3 over 4x into 1 is minus 3 over 4x. And then minus 3 over 4x into minus 3x is going to give me 9 over 4x square. And I don't need to multiply any further because we have to keep this up to x square. So, bacho, this is going to be 2 and this is minus 2x, and this is minus 11 over 4x, it's 36 9, and this is going to be 10x squared. Let me check the answer because I'm not sure if this is really correct. uh, this was what question, beta? Question number? No, I think this is question number 8. uh, No, 9 tha. Okay, nine's last part, the expansion. Yeah, 2 minus 11 over 4x. Yeah, absolutely right. Thanks, God. So this is the right answer. Okay. So I'm moving to the next question. If I can really do that in these, uh, this is the question number 10. Okay, we have 8 minutes to do this question. Let's see if we can really do that. It's the diagram shows a curve this and its minimum point M. Find the exact coordinates of M. So this is simply a question of u dot v, kind of a like differentiation of a product here. So your u is 2 minus x and your v is e raised to power minus half x. Therefore, your u dash is minus 1 and your v dash is minus half e raised to power minus half x. Remember how we differentiate this. So this dy by dx, that will be kept equal to 0. This is going to be uv dash plus vu dash. Okay, so uv dash is going to be minus half e raised to power minus half x into 2 minus x, and then vu dash, that is minus e raised to power minus half x, and I put that equal to 0 because I have to find that minimum point. Okay, so e raised to power minus half x, and this minus half, I'm going to take it as common. This is 2 minus x, and there is going to be plus 2. Okay, this e raised to minus, if you put that e raised to power minus half x equal to 0, you get no solution from here. Okay, but this 4 minus x equal to 0 will give you x equal to 4. So that is the exact coordinate, x coordinate of, so we have to find the coordinates, not just the x coordinate. Now we put that into the equation. So we have y equals 2 minus 4 into e raised to power minus half into 4. This is minus 2 e raised to power minus 2, or you can write it as minus 2 over e square. Therefore, this point M is going to be, the answer is, the point M is 4 comma minus 2 over e square. Let me check the answer quickly. This is x equal to 4 and y is equal to, yeah, we have got the right answer. Okay, next it says find the area of the shaded region bounded by this. Give your answer in terms of E. Okay, we have to find the area here. Okay, to find this area. But you have to find this area, you need to have this point over here. What is this point over here? I think we don't need this M, so I'm going to erase all this working here. Okay, so let's find this point. Let me find this point. I'll be putting y equal to 0. So when you put y equal to 0, you have 2 minus x e raised to power minus half x equal to 0. So this is 2 minus x equal to 0, or this e raised to minus half x equal to 0. Again, there is no solution from here. Okay, but this will give you, if I write this a bit neatly, you can see this is 2 minus x equal to 0. So this will be giving you x equal to 2. So that means you have 2 over here. Now this area, the area is going to be uh, limit from 0 to 2. This is 2 minus x, and then e raised to power minus half x dx. You must have realized that this is going to be a question on integration by parts. parts. This is going to be a question on integration by parts. 5 marks. Again, don't be hasty. We have 4 minutes to complete that. This is going to be my u, and this is going to be my v dash. Okay, so if you have to integrate u v dash, just write the formula. That will be uv minus u dash v dx. Okay, so if your u is equal to 2 minus x, your u dash is minus 1. If your v dash is e raised to power minus half x, your v would be minus 2 e raised to power minus half x. Basically, you're going to divide with the minus half this time when you integrate it. Okay? So here we are, bacho. Let me integrate this without the limits first, and then I'll put the limits at the end. So this 2 minus x in e raised to power minus half x is going to be 2 minus x into e raised to power minus half x into minus 2 minus, this is minus 1 for the u dash, and then minus 2 e raised to power minus half x dx. This is going to be, let's write this again, minus 2 into 2 minus x e raised to power minus half x. We have minus 2 e raised to power minus half x left here. Okay, so this is now going to be this blah 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 limit from 0 to 2 is going to be minus 2 into 2 minus x e raised to power minus half x and plus 4 e raised to power minus half x, because this will again be integrated as minus 2 into all of this. So minus 2 into minus 2 will give you plus 4. If you want, you can take minus 2 e raised to power minus half x common here. You have 2 minus x minus 2 left here. Is that so? 2 minus x and minus 2 left here. So that is going to be, this is cancelled by this. This is x 2x e raised to power minus half x. Let's quickly put the limits into it. Limits from 0 to 2. So this is going to be, when you put 2, this is going to be 4 e raised to power minus 1. When you put 0 into it, all of this is going to be 0. So the answer is 4 over e units square or whatever. Let's check the answer quickly for this last part. And that is, yeah, 4 e raised to power minus 1 or 4 over e. Okay, so this is the question number 10. We shall do the remaining 2 questions in the next segment. Thank you very much, Bacho.